network address translation. Okay, now so let me tell you here, in the real world in the sense, suppose you are browsing the internet. Okay, this process of NAT takes place. I'll tell you, but now just let me draw a figure like this. Okay, now you got some computers and you got some switches. And you got some routers as well. I mean your router. Now suppose it is connected to internet. It's connected to internet. And from the internet it is connected to another organization. Then we have connected to the switch and then to the servers or the machines. Okay. Now let it be like this. So now, say to the left side of this line, what you have is called the our network, or it is called inside network. What do you call it? Called inside network. That is inside our organization. Okay. So to the left side, we got inside network. Okay. So this is the inside network. Inside network. And to us, this is the outside network. To the right side of the line, you have outside network. Okay. Now, so in the inside network, that is in our company environment, we'll be using certain IP address range that is called private IP. What is it called? Private IP. So you will use the private IP and you got a specific range for the private IP, which are 10.0.0.02, 10.255.255.255 for class A. For class A, this is the range. For class B, yes, 172.16.0.02, yes, 172.31.255.255, and for class C,
192.168,
yes, 0.02, 192.168.255.255. So these are the private IP ranges. These are the private IP ranges, and these private IP range can be used within our network. Okay, so wherever you go, in whichever organization you go, your inside network will be having any one of these IPs. Okay, so say it will be of this range, and of course you might have heard of this range, 192.168.1. and all, you might have heard of it. Okay, which is commonly used in our home and all. Okay, so this is the private IP range. Okay, now let me tell you here. So inside our organization, or in the computers and the switches and the routers, okay, I told you we will be using the private IPs. Consider that I am using the private IP range 10.0.0.0/24 range. So .1 can be assigned to the router, .2 can be assigned to the switch, .3 can be assigned to the computer, .4, .5, .6, etc. can be assigned to the computers and the rest of the machines. Clear? So now this is the private IP. This is the private IP. Or if you are using the private inside our network, or we'll be using the private inside our network, so that is called inside local address. What is it called? Inside local address. The private IPs are called inside our environment, are called inside private address or inside local address. Inside means it's of the inside the organization, and local address means it's the private IP. Clear? So this is the inside local addresses. Now suppose you want to communicate to Google. Consider this is Google or some other, say, website. Okay, so suppose ABC website. So you will connect it to the service provider. You will connect it to the service provider. So what happens is that, say, once you leave your organization, once you are connected to the outside world, you will communicate with the help of public IP. You will communicate with the help of public IP. So public IP, you will receive it from the ISP, from the internet service provider. You will receive that from the service provider. Did I tell you about the hierarchy? Okay. So the hierarchy, IP address hierarchy is that, say you got an organization called IANA. So IANA owns all the IP addresses, and then the IANA will give it to the continent. Say for each continent you have different RIR, organization called RIR, Regional Internet Registries. For Asia Pacific it's APNIC, for North America it's ARIN, and so on. Okay, now so APNIC, they will give the IP address to Tier 1 ISP. Okay, and from Tier 1 ISP, Tier 2 ISP will get, and from Tier 2, Tier 3 ISP will get, and finally the customers will get the IP address. Okay, so these are the public IP, and the public IP you will receive it from the service provider. Okay, so the service provider has given us a public IP. Suppose here it is 1.1.1.1. Okay, and here it is 1.1.1.2. Okay, now here suppose it is 2.2.2.1, here it is 2.2.2.2. Okay, now so this is the ABC organization. So with respect to ABC organization, considering the ABC organization, consider that we are a part of the ABC organization. If we are taking a look at from this ABC organization, this is their inside network. This is their inside network. But when we take a look from our organization, this is also the outside world, right? Okay, so now, so even those companies will be using, or they will be having the public IP at their outer end. Okay, and this address, say the public IP at our end, that is called inside. That means it is inside our organization, inside global address. What is it called? Inside global address. Okay, global meaning public. Okay, now here this is outside our organization. So actually this is our organization. Afterwards it is, say, beyond that, so you have the outside world. Okay, so this is outside, this is outside global address. Clear? Now, so inside the ABC company, they will also be using the private IP range. They will also be using the private IP range. And now the private IP range, suppose it is 172.16.0.0/16. Okay, or suppose it's 0.0, yes, 0.0/16 here, and here it is .1, and here it is .2. Okay, and these private IPs are called outside local address. Outside local address. Getting that terms now? Okay, so we have inside local address, which is inside private IP of our organization. Now outside local address, which is some other companies or some other organizations private IP. Now considering this outside local, so again let me tell you, these are the private IPs. The local IPs are the private IPs. Now we know our private IP, and our private IP is to be kept private with the others. It means it needs to be kept private in the sense we shouldn't be disclosing our private IP to anyone. It needs to be kept private. Similarly, the outside, the ABC organization's private IP is, say, that needs to be kept private. And we can access the public IP of that ABC company. We cannot access the private IP of that company. Clear? So suppose if at all you are accessing the Google and all, you are accessing the public IP. Okay, we really don't know whether they have a private IP or not, but we are only accessing the public IP there. Clear? Okay, so up to this 2.2.2.2 only we have the access, and after that it is their private IP. We are not concerned about those things now. Clear? Okay. Now suppose consider that this machine 10.0.0.3 wants to communicate to 2.2.2.2. What happens is that, say, this packet will be having the source IP, which is 10.0.0.3, and the destination IP. What will be the destination IP? The destination will be the public one, 2.2.2.2. So both are in different network, and the, say, packet will be sent to the router, our router. So what the router will do is that the router will perform a process called NAT. He will perform a process called NAT. So he will change the source IP. He will change the source IP to, so this source IP is a private one. He will change it to a public one. He'll change it to a public one. Suppose the public IP that he changed is, say, the source IP now is translated to 1.1.1.3, and the destination IP, it is 2.2.2.2. Okay, so then what the router will do is that he has translated this 10.0.0.3 to 1.1.1.3. Then it is sent to the service provider. So the service provider will be thinking, okay, 1.1.1.3 is sending something. Okay, so at that time the service provider doesn't know it is the real IP is 10.0.0.3 that is being translated. Clear? Getting it, guys? Okay, so simple thing. Okay, so the router, what he will do is that whenever he receives a packet which is destined to go from the inside network to outside network, this is the inside network, and it is going to the outside network, the address, the source address will get translated. The source address will be translated from the private IP which is used in our environment to the public IP which is used in our internet. Okay, so he has translated the IP to 1.1.1.3 and will be sent to the service provider. The service provider will send it to the ABC company, and say they will send the reply back. When they send the reply back, say it is to the 1.1.1.3 that they are sending the reply, not to the 10.10.10.3. Clear? Then it will reach the service provider. Service provider will, say, pass it to our router. The router will now translate it back to the private IP. So the process of translating the private to public and public to private, that is called NAT, network address translation. Clear? Yes.
When you are sending source IP is 1.1.1.3.
That maybe we have purchased it from the service provider. Okay, so that is a different IP that we'll purchase it from the, or we will get it from the service provider. Got it?
Our public IP is 1.1.1.1, right?
That is used in this interface. Okay, we can purchase another IP also.
Okay.
Okay, yes. Got it? Okay, Naresh. Okay. Now, so NAT, this is the process of NAT. So translating the private to public and public to private is called NAT, network address translation. Okay, now we are only concerned about translating the source IP at our end. Okay, now say again the destination IP and everything can be also translated, but we are not concerned about those things. Okay, now NAT are of two types. First is called static NAT. First is called static NAT, and the second is called dynamic NAT. Static NAT and dynamic NAT. Okay. Static NAT, let me tell you, static NAT means we will mention this IP. So whenever, say, 10.0.0.3 is trying to communicate, his IP needs to be changed to 1.1.1.3. Or whenever 10.0.0.4 is trying to, say, sending any packet, his IP needs to be changed to 1.1.1.5. We will mention this. say manually. That is called static NAT. We are mentioning it, so that is called static NAT. Okay, and the static NAT, the entries remains the same. The entries means, so whenever we configure it, say I told you when 10.0.0.4 is trying to communicate, his IP is translated to 1.1.1.5. so that will be a constant. We will not change it. Or whenever he tries to communicate, his IP will be changed to 5 only, not .6 or .7 or .8. The values or the translations will be constant. Okay, or the translation remains the same. Whereas for dynamic, say the translations are automatically done by the routers, we don't need to do anything.
Why we need this much of IP address? Means 4, 5, 6, 7 or 8 something.
4 or 5, yes, I'll tell you about that. Okay, so now we'll go with the concept. Okay, got it, guys? Okay, now that we will do the static NAT. Okay, first we'll do the static NAT. So now let me draw a figure. Static NAT. Suppose you have the router R1. Then suppose you got another router R2. Or this is the ISP router. Okay, and you got, suppose this is the Google. Okay, and this is our LAN. We got a switch here, and we got some computers. Consider that their IP is 10.0.0.0/24 range, and this is .1, .2, .3, .4, .5 and .6. Okay, and here you got an IP range, say suppose 1.1.1.0/24 range, and here it is .1 and here it is .2. Now suppose this is 2.2.2.0/30 range, here it is .1 and here it is .2. So suppose the Google server is having the IP 2.2.2.2. Okay, now so now let me implement it, guys. Just give me a moment. So 2 routers and 6 machines. So here 1, 2, 3, 4, 5. Okay, I suppose only 5. Now again the routers. Okay, another router and 1 server and 1 switch. Suppose this is the figure. Okay. You are given multiple computers, and this is the service provider router, and this say let me connect it here. So okay, now let me give the IP addresses as well. So just give me a minute or two while I configure the IP addresses and all. So here, notepad, yes, interface gigabit 0/0/0. The IP address here is IP address 10.0.0.1 255.255.255.0, or let it be, yeah, okay, then let me give no shut. Then interface gig 0/0/1. The IP address is 1 dot, I suppose 1 IP address is 1.1.1.1 255.255.255.0, and then let me give no shut. Okay, this will be done in our router. Okay, forgot to type one thing. Now then the next router was the IP 1.1.1.2. okay, 1.1.1.2 2.2.2.1. okay, so /30. so we'll go to this interface, yes, 0/0/0. then we'll be giving 1.1.1.2. okay, 0/0/0 1.1.1.2 and 0/0/1. then we'll be giving 2.2.2.1. /30 if I'm not wrong. Okay, 252. Again. Okay. Now let me give the IP to these computers as well. See here, just let me give it 10.0.0, say 2 255.255.255.0 and 10.0.0.1 is the gateway, and this is 4.3. .4 .5 and .6. Okay, now so this is the initial configuration we need to do. Okay, now what we will do is that, say we will do, or we'll go to our router and we'll do the NAT, static NAT. Okay, so the command to do the static NAT is like this. We'll go to the router's config mode, and then we'll mention the command like this: IP okay, just give me a moment. Okay, so the command is like this: IP inside, just again, nope, okay, IP NAT inside source static. Okay, IP NAT inside source static. That means, say the NAT needs to be done, whoever is coming from the outside, their source needs to be translated statically. Okay, their source address needs to be say translated statically for the packets coming from inside. Okay, so which address they need to translate? Again, let me tell you. So here, suppose I told you you have machines 10.0.0.2. Okay, when 10.0.0.2 is trying to communicate, let the IP be 1.1. So here you got 1.1.1.1 and 1.1.1.2 here. So the available IPs are .3 to .254 are available. Suppose these are the IP addresses that we purchased. Then what you will be doing is that you will be translating to any one of the IPs. So 1.1.1. Suppose 250. Okay, so this IP will be translated to 1.1.1.250. Okay, now the next, say 10.0.0.3 needs to be translated to 1.1.1.3. 10.0.0.4 needs to be translated to 1.1.1.4. Now 10.0.0.5 needs to be translated to 1.1.1.100, and 10.0.0.6 needs to be translated to 1.1.1.6. Okay, so we will be mentioning it like this. Manually you will mention, and that is called the static NAT. Okay, so shall we manually mention it? Okay, so here when we mention IP NAT inside source static, then we will mention the IP 10.0.0.2. For 10.0.0.2, translate its IP to 1.1.1.250. Okay, so we will mention it like that. Say 1.1.1.250. This is the command. Okay, and for the next machine, for 10.0.0.3, the IP needs to be translated to 1.1.1.3. For 10.0.0.4, the IP address needs to be translated to 1.1.1.4. For 10.0.0.5, the IP address that I told was 1.1.1.100. And for 10.0.0.6, the IP needs to be translated to 1.1.1.6. So these are the static NAT commands. If you have 100 machines, we'll have to give 100 commands like this. Yes, means say here we are giving the inside local address, and then we'll mention the inside global address. Clear? Okay.
If you have 1,000 computers, right, then we would need 1,000 IP address like this from the ISP.
Yes,
right?
exactly.
But actually, do they buy like that? No, right?
There is something else. We'll study it.
Okay.
Okay. Yes. Now, so this is the command. Okay. Now, shall we? Okay. Now, so I'll give you time to write the commands. Okay. Now, we know that this is the inside network. This fastnet 0/0 or fastnet 0/1 or the gigabit 0/0. This is the inside network. Okay. This is where you connect the machines or the internal machines. Okay. And this is the outside network. Say suppose gig 0/0/1. This is the outside network. That means say the internet is connected to gig 0/0/1. We know it as per the figure and as per the say connection. But the router also need to be mentioned like that. Okay, we will mention this as the outside interface. Gigabit Ethernet 0/0/1 as the outside interface, and gigabit Ethernet 0/0/0 as the inside interface also. Shall we mention?
Yeah.
Okay, so we'll go to the router again. We'll go to say interface gigabit Ethernet 0/0/0. Then we'll mention the command IP NAT. It is inside. Okay, then we'll go to the interface gigabit 0/0/1. Then we'll mention IP NAT outside. Clear? Okay. Then what you will do is that we will go to the router. Okay, we'll go to the router and we will give the default routing, because in case you are sending anything to Google, or in case if you are sending anything to Facebook or Yahoo or Twitter or whatever, okay, the packets needs to be sent to the service provider. So here we will give the routing in say our router R1. We'll give the default routing. Okay, so now the default routing will be given. So IP root, the command is 0.0.0.0, again 0.0.0.0. Then we will mention the next hop address. And what is the next hop here? Yes, 1.1.1.2. Okay, so 1.1.1. Clear? Any doubt? Okay. Now, so what happens? Let me tell you. What happens is that, okay, let me take the other Epic pen. Yes. So here you can see, say whenever 10.002 is trying to communicate, okay, so say he is trying to communicate to 2.2.2.2. okay, so what happens is that, say the packet structure will be like this. You got the source IP here 10.0.0.2 and the destination IP is 2.2.2.2. both are in different networks, so the packet will be sent to the gateway, that is the packet will be sent to the router R1. okay, R1 will check, or R1 is receiving it via the inside interface, and he will check and he will come to know that the packet needs to be sent to the outside interface. So if the packet is coming from the inside and needs to be passed to the outside, then he knows the NAT has to be done, the NAT translation needs to be done. Then he'll check this table called NAT table. He'll check this table and he'll come to know the source IP of 10.0.0.2 needs to be translated to 1.1.1.250. So what he will do is that this packet, the new packet will be having, so he will translate the IP. So now the new, the packet, the source IP will be 1.1.1.250 instead of 10.0.0.2. They will translate it to 1.1.1.250. Then the destination IP will remain the same, 2.2.2.2, and then it will be passed to the, say, ISP, the service provider router, and the router will check the destination here 2.2.2.2. it is directly connected, he will pass it to the Google server. Okay, now the Google, when he is replying back, say the source IP will be, what will be the source IP? 2.2.2.2. that means the IP address of this Google server itself. Then the destination IP, what is the destination IP? 1.1.1.250. So it will be sent to the service provider. The service provider knows who is 1.1.1.250. He will send it to our router, and our router who has already translated 1.1.1.250, so he will receive this packet and will translate it back to 10.0.0.2. Clear? So the router, what he will do is that he will translate from the public to the private, the private to the public, and also to the public to the private. Clear? And this process is called network address translation. Clear? Now shall we test it, guys? Okay, our topology. So here, so we'll go to the computer and we'll ping it. Okay, we'll ping 2.2.2.2. We'll see whether we are getting the reply or not. Yes, we have not given the IP here. Okay, so we'll just, let me give the IP 2.2.2.2, 255.255.255.252, and then this is 2.2.2.1. Yes. Now we'll see, we'll check whether we are getting the reply. You are getting the reply. Okay, so that means now we are getting communication to the Google. Okay, now again testing from the other machine. Again, ping 10.0.0, sorry, 2.2.2.2. You can see you are getting the reply. Okay, so all the computers here will get the reply. Now let me trace RT, then say 20 dot or 2.2.2.2. You can see it is first going to 10.0.0.1, which is our router interface. Then it has gone to 1.1.1.2, which is the service provider's IP, and then 2.2.2.2, which is to the, say, that server. Clear? Okay, so this is how you will connect it. And again, if you check the NAT table, if you can check the NAT table here, show IP NAT translations. This is the NAT table in the router. To view the NAT table, this is the command show IP NAT translations. Okay, so when you check it, you can see whenever 10.0.0.3 is trying to send the packet, or whenever 10.0.0.3 is sending the packet, so this is the inside local address, that means this is the inside private IP. Whenever, say, we are trying to communicate to 10.0.0.3, then 1.1.1.3, it is translated to 1.1.1.3. Whenever 10.0.0.4 is trying to communicate, his IP is changed to 1.1.1.4. Whenever 10.0.0.5 is trying to communicate, his IP will be changed to 1.1.1.100. Whenever 10.0.0.2 is trying to communicate, his IP will be changed to 250, like that. Clear? Any doubt in this one? Okay. So now if you want, you can note down this one. Okay, the commands. Do show history. Again, let me okay now, and this is the yes, this is how you will mention the inside and the outside interfaces. Okay, and this is the default routing. You can note it down. Okay, yes, either you can note it down or you can take a snap and paste it in the group also. Yes. Done. Okay, now that we'll be going with the dynamic routing. Okay, the same topology itself, let me do the dynamic routing for, say, not the dynamic routing, dynamic NAT. Okay, so to do the dynamic NAT, what we are going to do sorry guys, so now to do the dynamic NAT, what you're going to do is that I'm going to take away all the static NAT commands. Okay, I'm going to take away all the static NAT commands now. So these are the static NAT commands. Let me delete all the static NAT commands. Okay, so this is the, I've deleted all the static NAT commands. So now here, now when you check do show IP NAT translations, you do not have any translation, or nothing is there in the translation table. And if you try to communicate, if you try to ping, you will not get the reply because we have just deleted the translation. Okay, now what you're going to do is that, so I told you, so here what we have done is here we have mentioned the inside local address, and this is the inside global address. So here in the dynamic NAT, what we will do is that this inside local address will be mentioned or will be specified in the router using an ACL, and this ACL is called a reference ACL. It is used for reference. It is just to match it is just to mention the inside local address. We will not bind it to any interface. If you bind it, then it is blocking. We really do not want to block anything now. Okay, we just want to mention, or we just want to group them together and tell them this is the private IP. Okay, this is the inside local address. For that we will be using the ACL. Now here we will be using the standard ACL. Because here we want to represent the source only. The source. So we will use the standard ACL. Numbered or named, you can use anything. Okay, you can use numbered ACL or named ACL, it doesn't matter. Okay, so you will mention the standard ACL and you will mention the inside local addresses. Okay, then to mention the to mention the inside global address or the public IP, we will create something called pool. Okay, then we will group them together. Suppose we will group ACL and pool together. That means if at all anybody from the ACL is trying to communicate, then translate the IP to any IP in the pool. Getting it? The concept is that if at all somebody from the ACL is trying to communicate to outside world, translate that IP to any IP in the pool. Clear? Okay, so let me tell you how you can do it. The command is like this. Say we'll create a standard ACL. Right, suppose I'm creating a numbered ACL, standard numbered ACL. So access -list. And for standard numbered ACL, I can write the numbers from 1 to 99. So suppose it is 50. Then I'll use the keyword permit. So this is only for matching it. Okay, the matching the IPs I'm using it. So permit 10.000.000.255. Okay, because it's /25 for the entire network, the wildcard mask is 0.0.0.255. Okay, so we have just created an ACL. Then we'll create a pool. The command is ipnat pool. Then you will give the pool name. You will give a random name. Suppose test pool. Then here you can see in our figure, I told you .3 to .254 are available. We have purchased all the IPs here. So .3 from .3 to .254 are available. So we will give the available IPs. Okay, so 1.1.1.3 to 1.1.1.254, and the net mask, that means the subnet mask here, the subnet mask of the link is say /24 here, so the subnet mask will be 255.255.255.0. okay, so here we will give 255.255.255.0. okay, then I told you we will mention both ACL and pool together. Okay, so the command is you will mention both together. So the command here is say ipnat inside source list, then we will mention the list number, which is 50, or if at all you are mentioning the ACL name or the named ACL, you will give the ACL name here. Okay, and pool, then the pool name is test pool. So that means I'm just mentioning I need to do the NAT. Whoever is coming from the inside, translate the source IP from the 50, from the matched one which is in the access range or access list 50, then translate it to the any IP in the pool. Getting it? Yes or no? Ritik? Simple. Say again.
One more time.
Yeah. So do the NAT. from, say, do the NAT, say from the inside, say change the inside IP, okay, or just say change the, say you can tell like this, do the NAT whichever is coming from the inside interface, do the NAT, okay, and change the source IP. Change the source IP if it matches in the list. The source IP, if it is matching in the list, change the source IP. Change it to any IP mentioned in the pool. Now got it? Yes or no? The same thing that I told you. Okay. Yes, Naresh. Okay. Done, guys. So this is it. So now do show IP NAT translations. Sorry. Do show history.
What about interface?
Interface. Yeah, I'll come to that. So the interface we have not deleted, we have already mentioned it. Okay, that's also necessary. Okay, so IPNAT inside, IPNAT outside, and the default routing, that is necessary, and we didn't delete it. So that also should be mentioned. If you are doing it in a new topology, you should be doing it. Clear? So this is the command syntax for dynamic NAT. Dynamic NAT. Okay. Yes. So you can note it down, and then
Can you please explain that IP route, those 3 IP addresses? I missed that part.
This one is the default route.
Okay.
Yes. Done, guys. Okay. Now, shall we go to the next topic? Now, the next topic means in the sense in this itself. Okay, in the NAT itself. So yes, say previously I suppose it was Vijesh. Okay, Vijesh who has asked the question. So now, say now I've told you, you got 10.002, 3, 4, 5, 6, and you can see these IPs are getting translated to different public IP. So if it is getting translated to different public IP, that means we'll have to purchase these public IPs. We'll have to purchase these public IPs.
We have 1,000, 2,000, 4,000 machines.
Yes. Okay. So that is a problem. So if you have 2,000, 3,000 machines and all, you'll have to purchase 2,000, 3,000 public IPs and all, right? Which is not possible. Okay, because one public IP itself is costly. Okay, so to purchase say multiple public IPs, maximum will be having 2 or 3, maximum 3 public IPs. I don't think they'll be having above that. Okay, so or 2. Okay, the usual one is 2. So see, you will be having, say suppose consider that you only have a single public IP here, okay, which is 1.1.1.1, and we do not have any public IP here to use. So consider that this network is, instead of 1.1.1.0/24, say you have 1.1.1.0/30 here. If it is /30, you can have 1 and only 2. From 3 onwards, say 3 is the broadcast, and 4 onwards it's coming in a different network. Okay, so suppose this is the condition. If this is the condition, you do not have this much IP at your end. Okay, if you do not have this much IP at your end, you won't be able to use these IPs. 253, 4, you cannot use these IPs. So what you will do is that, say you only have a single IP at your end, which is the IP here, 1.1.1.1. Okay, so in this case, what happens is that whenever you want to translate the IPs, you will translate it. You will translate it, so everyone will get translated to a single IP. Everyone will get translated to a single IP. That means, say whenever 10.0.0.2 is trying to communicate, his IP is changed to 1.1.1.1. And whenever 10.0.0.3 is trying to communicate, his IP is also changed to 1.1.1.1. Whenever 10.0.0.4 is trying to communicate, his IP is also changed to 1.1.1.1. Again 1. So everyone will be translated to the available IP, which is 1.1.1.1.
Like home network.
Yes. Okay. So this is how it gets translated. Okay. Any doubt?
If everyone communicate at the same time.
If everyone communicate at the same time, yes. Say suppose if all the computers are communicating at the same time, that means if everyone is communicating, so whenever 10.0.0.2 is trying to communicate, their IP is also changed to, or his IP is also changed to 1.1.1.1. 10.0.0.3 is trying to communicate, his IP is also changed to 1.1.1.1. And 10.0.4, say same 1.1.1.1. Everyone will be changed to 1.1.1.1. And of course you will have a doubt. How will they distinguish it? Right? Or how will they differentiate? Say whenever he is receiving the packet for 1.1.1.1, the router will get confused, right? So whether he needs to translate it back to 10.0.0.2 or 3 or 4 or 5 or 6, right? So let me tell you how they will avoid the confusion. So whenever you send a packet, in the transport layer, you will have something called port number. What is it? Port number. So, sorry, when you send something, the source port number, when you send something from the client, the source port number will be a random one. The source port number will be a random one. So, the port number, suppose when 10.0.0.2 is sending the packet, at that time, suppose his port number is, say, 10,000. His port number is 10,000. So this will get, the source IP will get translated to 1.1.1.1, but they'll be having a port number of 10,000. Okay. Now, so if 10.0.0.3 is trying to communicate and his IP is translated to 1.1.1.1, but consider that he has got a port number of 9,000. So his port number here will be 9,000. And consider this time when 10.0.0.4 is trying to communicate, his port number is, say, 4,000. And this is 4,000. So what happens is that whenever they are receiving a packet for 1.1.1.1 with port number 4,000, then the router knows this is 10.0.0.4 with a port number 4,000. Clear? So this is how they will identify it. So again, whenever he receives back a reply for 1.1.1.1 with a port number of 9,000, the router knows it needs to be translated to 10.0.0.3. Clear? Okay. Now, so suppose 10.0.0.5 when he is communicating, say the port number, consider it as 9,000. Okay. Yes. So what he will do? He will translate it to 1.1.1.1 with a port number of 9,000. Can you translate? If he translates, you are having both here. Okay, then he'll be translating to some other value, maybe to 9001. Okay, then again say here suppose 7000, he'll translate it to 7000. Clear, guys? So this is called PAT, port address translation, which is done in the real world, which is done in the real time. Clear? So we'll not be doing the NAT, we'll be doing the PAT configurations now. Okay, and that is why if you have multiple, say if you have multiple devices in your home, suppose if you have a switch and if you have some computers, say suppose you got 3 computers in your home, 1 laptop in your home, and suppose a mobile phone also. When you try to communicate to the internet, right, all the IPs will be translated to a single one, and that single IP will be your public IP. Clear? Okay, so this is it, and this is called PAT, port address translation. Okay, port address translation. So now to do the PAT, let me change it. So I told you here we do not have that much IPs and all, right? So let me change it here, 0/0/1 and 0/0/0. Okay, so here let me change it. Show run pipe section 0/0/1. I'm gonna change it interface gigabit internet 0/0/1, and I'm gonna change this IP to 252. Okay, and here also I'm gonna change this IP 0/0/0. Sorry. How do?
About this,
Which one?
the wrong command.
This command. Okay, this you can press Control Shift and 6. Okay,
Control Shift and 6.
6. Control Shift 6, then release it and press X. Okay, so this what happens is that they are searching for a domain, I mean a name. Okay, when we type something, say some unknown commands, the router will think that it is a host name or something, and they'll try to establish a connection. Okay, if at all you are having say that error, and if at all you want to like delete, I mean like yeah, about this you can press Control Shift 6 and X. Okay, then if at all you need to like what do you say, this should not be happening, then what you need to do is that you can give like this, no IP domain -lookup. If you want to cancel, checking that in the domain name server DNS, then you will not have such errors. Okay, yes. Now let me come back. So I was configuring, say this one, gig 0/0/0. So do show run section 0/0/0. Just give me a minute. So after changing, we do not have any IP, we only have 2 IPs. 1.1.1.1 is used by our side, and 1.1.1.2 is used at the say service provider side. So now what you're going to do is say the configuration. So let me delete this dynamic NAT configuration. Okay, so I'm going to delete this dynamic NAT configuration. But guys, did we check the dynamic NAT? We didn't check it, right? Okay, so make sure that you check it. Okay, then check it on your own and then understand it. Say whichever IPs are translated to whichever and all, you can check it. Okay, now again, so now, so suppose that here, yes, so now there's only a small difference in the configuration of PAT, port address translation. So the difference is here, the access list and everything will mention it exactly the same. Now say the pool here, in the pool we do not have this much IP, we only have a single IP, which is the IP 1.1.1.1. so the starting IP and the ending IP both will be same. The starting IP and the ending IP both will be same, 1.1.1.1. Now the net mask, you will give the subnet mask correctly. For here the subnet mask is 255.255.255.252. Then here, say the third one, what you are going to tell is IPNAT inside source list 50 the pool test pool. Then you will add a keyword called overload. You will add the keyword called overload. So say as we are giving this keyword overload, PAT is also called NAT overload or overloaded NAT. Okay, so now this is the configuration. Now when you implement this one, you can see, yes, this has been implemented. And now when you try to communicate, let me just show it to you. You are getting the reply from 2.2.2.2, and here also you are getting the reply from 2.2.2.2, and here also suppose say ping 2.2.2.2. You're getting the reply, and here also when you ping 2.2.2.2, you're getting the reply, and here also when you ping you will get the reply. You're getting the reply. Now when you take a look at the NAT table, show IP NAT translations, you can see here 10.0.0.6 is trying to communicate, his IP is changed to 1.1.1.1. 10.0.0.4 is trying to communicate, his IP is also changed to 1.1.1.1. 10.0.0.5 is trying to communicate, his IP is also changed to 1.2 is trying to communicate, his IP is also changed to 1.3 is trying to communicate. So everyone is trying to communicate, and all the IPs are translated to 1.1.1.1 only. Clear? Everyone is getting translated to 1.1.1.1. Okay, and you can see it. Say whenever they receive 10.0.0.3 with a port number of 8, then the whenever they receive the reply for 1.1.1.1 with a port number of 8, they will translate it back to 10.0.0.3. Clear? So this is the PAT, port address translation. Now dynamic NAT, when you check, we didn't check the dynamic NAT. When you check, you will be having different IPs, like what we have seen it in the static NAT. Clear? Any doubts in the concept? Yes or no? Okay. So this is the PAT, port address translation. Clear? So this is the command for the PAT also. These three commands, and then the rest are same. Done? Okay. Now shall we move to the next one? Okay. Yes. So this is the NAT and PAT topic. That is done. I hope nobody has got a doubt here. Okay. Now that again we'll go to the next topic. Let me take so ACL and NAT are completed, and now shall we go with some theory? Fine with theory? Sure? Okay. Of course we have to go with the theory one day. Okay. So WAN protocols, or say, let me just ask you, port security, the channel, everything here, this is completed, right? All this is completed. Okay. Now have we done this one? NTP, AAA, SNMP, CDP? No. Okay. SSH is done, right? Okay. Now it is done. Okay. Now CDP, LLDP. So we'll go with some small configs now. Okay. So this one is CDP, but it will be say done within 5 or 10 minutes. That's it. Small config. So now let me go with what is called CDP. CDP, LLDP, NTP. Okay. So you can write the heading CDP. CDP. CDP here means Cisco Discovery Protocol. Cisco Discovery Protocol. So CDP or Cisco Discovery Protocol, let me tell you what it is. Here you have Cisco devices. So here it is Cisco device. These are Cisco devices, Cisco routers. So now here, to find out the directly connected or to find out the connected Cisco devices, we use the Cisco Discovery Protocol, say protocol or CDP. Now to view the directly connected Cisco devices, the command is show CDP neighbors. The command is show CDP neighbors, and you can see, yes, the neighbors here. Show CDP neighbors, and you can see to this router, this is the middle router. This middle router is connected to a switch and it is connected to another router. Both are the Cisco devices. So it lets you see the connected Cisco devices.
Only directed connected.
Yes. So here you can see switch and router. Now switch here, it has got a platform 2960 series, and router it is ISR 4300. Okay. Then to view the descriptive details, you have the command show CDP neighbors detail. Show CDP neighbors detail. So here you can see the descriptive details. So switch. Okay. The device name, this is the host name. I have not assigned any special host names, it is the usual one. The host name is switch itself, and I have not given an IP address. So if I would have given an IP address, it will show the entry address here. Then the platform is Cisco 2960 series, capability is a switch, and it is connected to this interface of this router. Okay, it is gig 0/0/0, and the outgoing port, that means the interface of the switch is fastnet 0/6. Then the version, the Cisco iOS version, it shows. Then you can see the duplex mode as well. Okay, the same thing here. So the same thing means, say the router here, the device ID, the next is the router. If you give another host names, you can see R3, R4 and all. If you give the host names, you can see it. Then the IP address is 1.1.1.2. It is the router is configured with IP address 1.1.1.2. So the platform is Cisco ISR 4300 series router. Okay, then the interface, the outgoing port and all, you can see the iOS version. Clear? So this is how you will see the the neighboring Cisco devices with CDP, Cisco Discovery Protocol. And this is a Cisco proprietary protocol. Right. Now, similar to CDP, you have another protocol called LLDP. You got another protocol called LLDP. LLDP means Link Layer Discovery Protocol. Link Layer Discovery Protocol. LLDP is IEEE's.
Open source.
Yes, open. It's IEEE. It's developed by IEEE. And you can see not only the Cisco device but also other vendor device also. Okay. But you need to enable the LLDP in the Cisco devices. To view it, you need to enable the LLDP in Cisco devices.
Other devices? Like
Other devices, don't know. Okay, maybe they would have been by default, it might be enabled, or you need to enable it. Don't know about that. Okay, so here we'll go to the switch. To enable the LLDP, the command is we'll go to the config mode and we'll mention the command like this: LLDP run. LLDP run. Okay, so this is the command. LLDP run. And again we'll go to the next router here. Okay, this device. Again we'll go to the config mode. LLDP run. Okay, everywhere we'll give LLDP run. Okay, then to view the devices you have the command. The command is show. Previously the command was show CDP neighbors. Now the command is show LLDP neighbors. That's it. Show LLDP neighbors will display the same output. You got a router and the switch. The local interface is there. The port ID is there. Port ID means the interface of the other device. Okay. Now again, to view the say descriptive details, you have the command show LLDP neighbors detail. You can see the descriptive details of the devices. Okay, so you got say the chassis ID, you can see, say the port ID, you can see the system name, that means the host name, you can see the description, the iOS version, you can see everything here. Clear? Okay, so this is the LLDP. Any doubt in LLDP? Okay, yes. Now the next one, NTP. So NTP is a different protocol. It is network time protocol. Network time protocol. NTP. So it is very much essential to synchronize the time between the network devices. Okay, we need to synchronize the time between the network devices. For that we will use NTP, network time protocol. In NTP, so if you will have an NTP server, you will have an NTP server in which you will configure the clock time, right? It's related to time. We will configure the clock in the NTP server, and we got another device called NTP client. NTP client. So the NTP client will get the time from the NTP server, right? So nowadays your phone, you don't need to set the time. The time will automatically come, right? So you will get the time from the service provider. How will you get the time? By using or by synchronizing the time with the say the other devices at the ISP. Clear? So similar thing, you will synchronize the time with the service provider, or you will synchronize the time with the say your local device. Clear? So now, so suppose that this is the server. Okay, let me rename it. This is the NTP server. Okay, and this is the NTP client. Now suppose, let me change the host name also. Host name is say NTP server. Okay, and here it is NTP client. Okay, now that we have given the host names, Now to configure this as the server, what you will do is that you will go to the config mode and you will mention it like this: NTP master, NTP master, then a number also you can mention, say that is called the stratum number. That means say how much trustworthy the time is. Okay, so considering the time in your watch, in your wristwatch, and the time in your phone, which one is trustworthy? The phone time is trustworthy, right? Similarly, if at all you have some other masters, okay, or the NTP servers, other NTP server, you got another NTP server here. So whether to trust this one or whether to trust this one. Okay, so that is the stratum number. Okay, now so here you have mentioned it. Okay, NTP master, this is the only command. So now again, but again I told you, do show clock. You need to do, or you need to configure the clock here correctly. Okay, so now the clock is showing 1993, some random values it is showing. I'll configure the clock like this. NTP, how to set the clock is like this: clock set. Then you will set the clock like this. Suppose it is 9:36:00. Then it is 27 May 2022. This is how you set the clock. So now when you show the clock, you can see this is the clock, May 27, 2022. So the NTP server is set with a clock now. Okay, now you will go to the NTP client, synchronize the time with the NTP server. So in the client, let us see the clock. Show clock. You can see it is still 1993, and I'm not gonna manually change it. Okay, it has to synchronize itself with the NTP server and get the time. To configure this as the NTP client, we'll go to the config mode, we'll configure it like this: NTP say server, then we'll give the server's IP, and the server's IP was 1.1.1.2. Clear? Now again, show clock. The clock is still 1993. It will take some time for synchronizing. Okay, it will take some time for synchronizing, so let me fast forward it. So after some time you can see, yes, now the time has automatically changed. Previously the time was 1993, now the time has automatically changed to 2022. How did it change? It got synchronized to the NTP server and it has got the clock. It has got the time. Clear? Okay. Again, you can see another show command, show NTP status. Show NTP status. So here you can see the clock is synchronized. The clock is synchronized. Okay, and the reference clock is 1.1.1.2. That means the NTP server is 1.1.1.2 here. Boring? Always sitting like this. Oh God. But he'll tell, no, it's not boring. Okay. Yes. Second. Okay. Yes. So this is the NTP. Network time. Done. Okay. Now again we'll go to the next concept. Say, let me check which one. So but still this is also theory. Okay. Yeah, we'll go with that. Okay, we don't have any options. We have, say, these things. Have I taken this one, GR proxy R by CMP? No. Okay, I'll take, let me check if I can take, I have the time, then I'll take that also. So let me go with AAA, SNMP, Syslog and theory. These are the theory. Okay, so AAA, or let me take I'll come to that also. First, let me tell you about SNMP. SNMP is simple network management protocol. Simple network management protocol. Network management in the sense you need to manage the networks. Okay, so I'll make it short. We have lot of theory portions. I'll make these things short. Okay, so suppose that, say, so far we have been studying about how the router and the switches work. Now we are concerned about the router and switch. The router and switches health and all. Okay, so if you have the routers like this and if you have the switches like this. So here this router here, of course they'll be put it in AC and all, so that they have the, or say for the cooling purpose and all, you will put it in the AC. Okay, now still we will keep on checking the temperature of these devices. The temperature will check, the fan we will check, the power supply we will check, like that we will check the condition of everything. So checking the condition of everything of the devices, that we'll use it via, or we'll do it via SNMP protocol, simple network management protocol. Okay, so the layer 7 used to monitor the device and manage the network devices. So what happens is that, say in these devices, when you do the SNMP, you will enable SNMP agent here. You will enable SNMP agent in the networking devices. Okay, and the SNMP agent consists of many values. MIB, management information base. It consists of many values. Okay, so the health related things, those things and all will be there in the MIB, management information base. Then say you will have another external server in which you will install certain softwares, and this software is the SNMP manager. SNMP manager. So the SNMP manager will keep on sending certain messages to the SNMP agent. They will send certain messages. These messages are get message and the set message. Get the temperature value, get the fan status, get the this value, that value, like that. Now set means set the temperature to 23 degrees Celsius or 24 degrees Celsius. If at all it reaches the threshold, you should notify me. Clear? So get means is the read message. Set means is the write message. Okay, now in response to the get and set, these SNMP agents will send certain messages called trap and inform. Trap and inform. Trap does not have the reliability, but inform has got the reliability, whether it has been received by the manager or not. Clear? Then, so here we will monitor the status, the health of the devices, the network devices, and that's why we use SNMP. SNMP, they got different versions of SNMP. Say SNMP version 1, version 2, version 2C, version 3, etc. Where version 3 offers many features, encryption, message integrity, etc. Okay, so these are the SNMP, simple network management protocol. Again, it's the theory only. Okay, you can check in the textbook. So the textbook will be having some theory. Along with that, you can have some commands as well. Those are, say we do not have the SNMP manager, they have not mentioned about the manager, so we are not implementing that one. Okay, yes. Now say you can read it. Say SNMP is used to automatically discover, monitor, manage the networking. I will upload this today. Okay, if you didn't find it, then let me know, I'll upload. Now so SNMP components, SNMP manager, SNMP agents, MIB and object ID. I told you have MIB, and in the MIB you will have lot of values which are called object ID or OID. Okay, so now, so this is the SNMP, simple network management protocol. SNMP messages also are told. Now then the next one is Syslog. Okay, Syslog, system log messages, that's the Syslog. So now when you take the devices, say you can see certain messages like this. So this message, translating this message, the interface change to up or down, that message. So those messages are the syslog messages, system log message. The protocol used to send system log messages, that's the syslog protocol. Okay, now by default the messages can be seen in the console. Okay, so these messages, say suppose the interface has gone down or the interface has come up or it has been synchronized, say, or say the time, the clock has been updated. So those messages are called the syslog messages, and it can be by default seen in the console. It cannot be by default seen in the VTY, say ports and all. It can be by default seen in the console. It can be saved to a server also, that is called the syslog server, and it uses UDP or TCP. Okay, just some theory. And these are syslog messages. If you can see it clearly, just a minute. Okay, so this is it. So here you can see the interface status changed to administratively down. Okay, so here you can see this. So the interface gig0/1 changed to administratively down. So this is an example of syslog. So the syslog contains many things here. You can see it consists of the time, at what time it has happened. Okay, and it consists of what the issue is. Say the link changed. Link change means the status of the link might have changed, or the OSPF adjacency, you might have seen that, ADJ adjacency formation. Okay, so like that it will tell you in briefly what it is. Then it will tell the message, and among that you can see a number, how much important this message is. So 5 here, it means notification, it is not much of important. So here 0 and 1 is having the highest impact, or it is the highest, very highest important one, which is severe to the router. Now say 2, 3, 4 are critical error and warning, which is again impactful. Now 5 and 6 are normal messages, and 7 it is debug message. Only if you enable it you can see the debug messages. Clear? Okay, so this is the syslog message. I hope you have understood the syslog as well. Yes or no?
Yeah.
Again some theory, that's it. Okay, now the next theory is AAA. So AAA authentication, authorization, authorization and accounting. This is the AAA, authentication, authorization and accounting. Okay, now let me just tell you what is authentication. Authentication means identifying the user. When you enter into the router will ask for the username and password. So it is authenticating. That means it will be asking for the username and a password, and will be checking whether the username and password is right or not. That is authentication. So if you have multiple devices, say multiple switches and multiple routers in your say environment, you need to configure all the users in each device, right? Yes or no? Okay, so there you will not be configuring it like that. Instead you will have a server called AAA server. You will have a server called AAA server. So the AAA server will be having these credentials. Okay, so in the router and the switch will be connected to the AAA server. That means via the network it will get connected to the AAA server. And whenever you are logging to the router will say, you will provide the username and password, and at that time the router will ask the AAA server, hey AAA server, somebody is trying to contact or somebody is trying to log into me, is this the correct username and password? Clear? So if at all it's the correct username and password, the AAA server will authenticate the username and password. That means they will check whether the username and password is correct, and if it is correct he will tell okay, allow him. Clear? So this is the authentication. Now the authorization says how much access you have it. How much access in the sense whether, say suppose you are a junior network admin. In that case you will not be able to get into the say the configure terminal, the global config also. So when you type the command, it may tell you do not have the authorization, or it may throw an error. Clear? So that's the authorization, how much authority you have to execute certain commands. Okay, and accounting, say whatever you do will be accounting. That means whatever you do will be tracked and will be saved it. Monitor what the user does. That's the accounting part. Clear? So to do the AAA or to implement the AAA, you have two protocols. One is called Radius and the other is called TACACS. So Radius here means remote authentication dial-in user service, and TACACS here means terminal access controller access control system. Clear? Okay, so this is the AAA. Okay, and these are smaller things, guys. Okay, so these everything here is the application layer. Okay, so the SNMP, the Syslog, the AAA, the FTP, the TFTP, everything is then it works in the application layer. Okay, and FTP it is used to transfer the file from one host to another, and it uses the port number 2021 TCP, and you can download or upload files from the FTP server to the client, and it is reliable transfer protocol. Okay, and you got a miniature version of FTP which is called TFTP. Is a lighter version of FTP. Okay, to transfer the files on configurations to and from the devices.
What will be the difference?
The difference is that one uses say TCP and the other uses UDP. Okay, that's one difference.
TCP.
Yes, FTP uses TCP and TFTP uses UDP. And FTP you can transfer larger files, but UDP it will be used to transfer smaller files, the configurations and all. Clear?
If there is any megabytes like that.
Yes. Okay. They have not mentioned any megabytes or something, but usually we'll be like having the larger files. Okay. So this is how it is. Any doubt in this theory?
So while you're explaining, you're telling about that port number.
Yeah.
I really don't know what is it. I don't
Port number I have taught you, right? Yes or no, guys?
thought, but
Port number is used to identify the protocols. It is there in the transport. Say suppose, okay, if you got computers, say I might have told you the same example that day also while teaching in the OSPF.
yes.
Okay, if you have computers, right, say the computer here, this computer is having 10.001 and this computer is having 10.002. So in the transport, so in the packet level or in the network header, the source IP will be 10.001 and the destination IP will be 10.002. And these two machines can send multiple messages, lot of messages. To identify which protocol or which message it is, you will have the say port number. So if it says port number is 1000 and this port number says it is 2000, you have different port numbers. Then the computer will understand, okay, there is one port number and he will be replying back for the port number 1000. And say then the computer will come to know this is this reply. And for if you've got a port number 2000 and he will be replying for the port number 2000, that means this computer can identify, okay, this message is for this protocol or this is for another message. They can identify the messages using this protocol, the port numbers. Got it? Got it? Or do you want more explanation?
I understand, but if you are sending that same UDP messages, that same 1000.
Suppose, let me tell you. Okay. Suppose if you are sending this computer to this computer. Okay. You are sending one message. So if this message will have in the transport layer, it will have a source port number and the destination port number. So the source port number will be a random value. It will change for each and every message you send, it will change. So suppose it is 10,000. And the destination port number, suppose you are browsing the internet, Google searching, you are doing it. So suppose this is a Google server. Okay, then the destination port number, so you are Google searching it or you are using the HTTP or HTTPS service. If you are using HTTPS service, then the destination port number will be 443. Say suppose you are browsing say Shahrukh pictures, SRK pictures. Then you are again in the next tab, you are browsing Rolls-Royce pictures. Rolls-Royce pictures. So at that time, the source port number will be 10,001 or 10,002 or 10,003, suppose 20,000, something like that. So suppose it is 20,000. Okay, and the destination port number, you are Google searching it. So again HTTPS. Okay, so the destination port number will be 443. So yes, Google will be sending back a reply. For both, he will send back a reply. Okay, and this has to be distinguished or this has to be differentiated. So at that time, say for whenever he is sending back a reply for this message, then the destination port number will be for 10,000. Then this computer understand it is for the Shahrukh pictures that he has replied. Okay, now if he is sending back a reply for this message, the second message, the destination port number will be 20,000. Okay, and when he gets, this computer gets the message, he will understand this message is for the Rolls-Royce pictures. Clear?
So from the sender side, the port number will be changed.
Yes, the port number will be a random value.
Random.
Okay, yes. Clear? That means the client client side it will be random. Okay. Clear, guys? Yes. So this is the FTP and the TFTP and the protocols. Okay. Now which one we will go. FHRP, if I say take it, it will take some more time. Okay, so we only have 5 more minutes. IPv6 WAN Metro Ethernet and everything will take also some time. Okay, so what do you say, guys? Want to wind up or wind up? Okay, it's your choice because today I've started it a little bit late, right? Okay, so wind up or still continue for some more time? What do you say? Sorry? Okay, continue. Okay, let's check with, yes, we have some pings here. Okay, Srikanta, so I'm having DR activity 10 AM, please allow me. Okay, so in that case, okay, you can leave, Srikanta, no worries. Okay, he has already left. Need to join the DR bit early. Okay, then in that case we can wind up. Okay, as you are, even you are also told to continue, but still.
Maybe 6 more minutes.
Okay, we'll wind up. No worries, even if we take a little late also we'll complete it.
You also have some small topic on firewall.
Firewall, it is there, but it's a theory only. Okay, they have mentioned about the firewall, but nothing is there to explain. That's what I think. Firewall is there. They have mentioned about the next generation firewall, NG firewall, and IPS and NG IPS they have mentioned. Okay, so you can read it. Okay, you can read the firewall, only the theory, the security things and the theory like this we'll explain. Okay, so you can read it, and in case of any doubts you can ask me. Okay, yes. Okay, guys, yes, thank you. So we'll get back on Monday then.